Hello, my name's Leah,
And I'm Marilyn.
and we did our project on titration analysis of water. So, our original hypothesis for our experiment is to collect water samples from different sources, such as tap water, river water, well water, and see if they contain various concentrations of heavy metal ions. It is hypothesized that samples from areas with greater industrial or agricultural activity will exhibit higher concentrations of complexible heavy metals such as calcium, magnesium, zinc, copper, and lead. As determined by complementary titration using EDTA, therefore, the degree of titration, which is the volume of EDTA required to reach the endpoint, will be greater with samples with higher heavy metal content. You want to tell them our materials?
Yeah. Materials needed for the procedure. Do I have to say this? The EDTA titrant, calcium standard solution for the EDTA standardization, ammonium chloride buffer, a black tea indicator, deionized water, flask, pipettes, burette, the magnetic stirrer, and sample bottles. We did have to prepare a reagent, but we did not have the EDTA when we, started our actual procedure. So,
since the EDTA wasn't available, and our original hypothesis said that we're testing for like lead, calcium, different heavy metals such as that, we figured out that we could use silver nitrate to titrate the water, and what's it called? When it becomes a solid,
it's
to precipitate the solid, and for chloride. So we went ahead and did that instead of using the EDTA because it wasn't readily available to us. EDTA is what the EPA actually uses to test for these heavy metals in cities all across America to make sure our drinking water is safe. So for our experiment, we didn't use, we wanted to test drinking water safety. So we used bottled water, tap water from the sink, which from this area is an industrial area, and the water from my water filter at home.
Also deionized water, which we know we won't have much change. And just to clarify, the drinking water we tested was Zephyr Hills brand water.
Zephyr Hills bottled water, yes. So after we did our initial kind of reaction to see if a participant would form, and we found that it would, and we'll go ahead and show you pictures of that after we explain a little bit more. The tap water needed 0.1 milliliters of our, what was our molarity?
Silver nitrate.
Of our 0.1 molar silver nitrate solution. The deionized water had no reaction at all. There was no change no matter how much we titrated it. The filtered water took 0.9 milliliters of silver nitrate to form that kind of thicker cloudy consistency. And the Zephyr Hills also took 0.9 milliliters, but it doesn't really matter how much we put inside to form the reaction. It matters the concentration of the cloudiness in the reaction. So the deeper, more cloudy white, it kind of looks like milk. The more milky the water looks, the higher concentration of chloride.
In my opinion, shockingly, the Zephyr Hills is more, gives that more cloudy, reaction.
Yes. So right here, we can see, I believe this is the tap water, this is the filtered water, and then we have our DI water completely clear, and this is the bottled water. So the tap water was pretty cloudy. It had formed a lot of precipitates, but it's treated by the city, but it's not what people typically use for consumption. But yes, we were surprised that the bottled water, even over time, after we took this picture, it continued to form precipitates.
Yep. And the reaction is literally, as soon as the silver nitrate meets the water.
As soon as it meets the water, it forms that cloudiness.
It just starts floating throughout the whole water and it takes over.
So this happens because of the silver ions forming the chloride compound, AgCl. which is a solid. So that's why we see that kind of milky color. And we figured this out by looking at the solubility charts and seeing what was insoluble with chlorides, which is one of the things that our hypothesis was testing on. And we found that we did find a lot of things that were soluble, but when we were testing them, a lot of the compounds weren't showing up in the water. So I assume that the chlorides are a little bit safer for our bodies to break down, rather than lead or something like that being in drinking water.
What is the